Hi there. This video is going to take a look at the issue of energy and food miles. And this is a third video in a series looking at the relationship between population, consumption, and the environment. And when it comes to food, one of the big concerns is food miles as far as energy consumption. So for every calorie of consumed food, there's about 10 calories of fossil fuels burned to deliver that food. So that's an indication that our current global food system is highly inefficient just from the standpoint of energy, right? Energy consumed, energy burned in transportation. And from that point of view, local food could be the answer, right? Because if we're not moving food as far, then if we were able to consume food close to where it's produced, we're not going to be wasting as much fossil fuel transporting it. But not so fast. Local food may require extreme levels of energy or water to produce. So if your local environmental conditions are not conducive to the kinds of food that the population wishes to consume, then it can be quite costly to raise that food, right, where the environment is not conducive because you're going to need greenhouses, you're going to need irrigation, etc. So there are those types of challenges that could also exacerbate the demand for energy. Third, eating food that is either out of season or not native to the local system is of course going to increase food miles. So people can adjust their diet, and that's probably the best thing is the local diets reflect local growing capacity. If those things align, then all is well. But uh, current consumers expect pretty much any type of food to be available year round because our global food system currently supports that, but the bill is very high when it comes to energy. So, how do we measure food miles, which is really the amount of food relative to the gross miles that are traveled? So, here's an example of Japanese mandarin oranges that are shipped to San Francisco. So, if we have a million tangerines that are going to travel 5,100 miles across the Pacific Ocean from Japan to California, then if we just do the math, that means it's 196 miles traveled per tangerine. And of course, the way that travels is going to matter. If it's on a plane versus on a boat, that's a big difference because jet fuel is a lot less efficient. But just looking strictly at miles, we can get into the efficiency of modes of transportation separately. But 196 miles per tangerine is the ratio, which works out to this number in terms of tons of tangerines per mile if you want to convert it to that. Now, coming back to the question of mode of transportation, you can see that if we compare water to rail, which of course rail is not really an option from Japan to California, but if we're moving produce from California to other parts of the United States, rail does come into play. Rail comes after water in terms of efficiency, and then we move on to road, but you can see rail is far more energy efficient than road travel, which of course is far more energy efficient than air travel. If we have to fly food around, that is the least efficient way to move it. And you can see that reflected in terms of energy consumption, kilojoules per ton, 15,000 for air versus 2,800 for road, so that's about 7 times uh, heavier. Rail consumption 677 versus water 423. So of course we want to move as much as we can by water, uh, followed by rail, and that's going to be reflected in terms of carbon emissions, which contribute to climate change. So you can see the impact there. In terms of the uh, grams per ton, right? The emissions measured as grams per ton, 1.2 million carbon dioxide grams per ton for air versus 207,000 for road, versus 41 and 31 for rail and water, respectively. So, the climate impact is going to be greater where the energy demand is higher. Right? And that also has consequences for VOCs, for nitrous oxide, and for carbon monoxide as well, which is important for things like smog and overall air pollution. So all this comes down to diet, right? The way we wish to eat food, the expectation consumers have for what will be available at the grocery store. Our diet shapes our consumption patterns. Uh, Weber and Matthews find that food transportation actually accounts for only 11% of the greenhouse gases in food production. So if we look at the overall process of food production from agriculture through distribution to retail, that the actual transportation part is only 11%. Especially when we're talking about meat, because as we've talked about in other places, raising meat often implies clearing forest, which means we're also removing carbon sequestration abilities of the planet to absorb carbon dioxide at the same time that we're expending carbon dioxide emissions in production. So red meat is 150% more energy intensive than chicken or fish, largely because of the amount of rangeland that's required to feed red meat cattle in general. And even if it's not rangeland, then it's cropland to grow corn or whatever kind of animal feed will go into feeding these herds of cattle. So what that means is shifting less than 1 day per week's worth of calories from red meat and dairy products to chicken, fish, eggs, or other vegetable-based diet will achieve more greenhouse gas reduction than buying all locally sourced food. So if you really want to limit your carbon footprint with your diet, you don't have to become a vegan, but just maybe replacing one meal could go a very long way. Uh, Much further than just buying local alone. Of course, doing both is really ideal. Uh, Bomford found that eating well is less intensive than eating junk, right? So it's good for your health and for the environment. So about 50% of energy in the food system goes to highly processed junk food. So which is not just bad for your health, it's energy intensive, it's bad for the environment, it's bad for the climate. 20% of energy goes to grains, fruit, and vegetables, which are going to give you the more healthy outcome for the population. And 30% goes to meat, eggs, and milk, right? Protein sources in general, which are not all bad for your health, but not necessarily good for the environmental consequences. But here's another important point. Retail stores consume a great deal of energy uh, just based on refrigeration alone. You ever go to the grocery store and go through the open air refrigerator aisles where you stand there kind of freezing and hoping to move along quickly because it's so cold? But what a waste of energy that is. Just putting doors on refrigerators would obviously improve the efficiency, yet retailers continue to offer these open air refrigeration systems because of the aesthetic appeal it has for consumers and so forth. But there's just a lot of inefficiency with how retailers are presenting and storing food. Now, of course, refrigeration is important to prevent spoilage. Otherwise, we're going to be dealing with a high rate of food waste. And so refrigeration isn't all bad. Without it, we'd have a greater food waste rate, and that also would be an inefficiency. But coming up with more efficient methods of refrigeration would certainly go a long way in terms of improving the carbon footprint and the overall energy footprint of food, especially on the retail end of the system. In terms of methods of farming, labor-intensive farming methods, because we're not driving machinery around, we're using human energy, for instance, or animal energy, a lot less fossil fuel based. So the carbon implications are going to be much better with labor intensive foods. So usually that also implies smaller scale production. So not having mega farms, but having more small farms that are operated with manual labor rather than machinery would be good in terms from an energy perspective. It may not be good from a profit perspective, but that's the kind of things we have to balance. So what we've been doing here is really using a life cycle analysis, looking at agri-food from start to finish, how do we maximize the energy efficiency of food? And so study of food energy at different stages highlights the need for a life cycle analysis. And this gives us a bigger picture, right? Not just focusing on one piece of it, like transportation, although that is an important piece. It's certainly not the only one. And so this reduces the potential for footprint shifting, right? So let's say we get rid of transportation by having all local food, but then we wind up using highly intensive farming methods to produce certain types of food that are not grown locally very well. So that would just be shifting from one problem to the other, not really solving the problem. So overall, our global food system, we see that 65% of energy is in the production stage, especially because meat is such a big part of our food production system. After that, another 12% goes into manufacturing, especially with the highly processed foods we mentioned, like junk food. Another 12% is in retail, right? The refrigeration and so forth that we were discussing. And then after that, consumer use, because consumers also use refrigeration and other types of cooking methods to prepare their food. That's also part of the energy bill, 9%. And then finally, disposal is another 2%. So that's the full picture. So you can see production is really where a lot of the focus could lie. In terms of the food energy breakdown, the amount of energy expended to produce food, we can see that oils, sugars, and other processed foods are a big chunk, right? 5,500 calories. Again, just eliminating some of the processed food and beverages, right? Your sodas and so forth. Also highly energy intensive, would go a long way in just eliminating the energy demands of our system, or food and beverage distribution system. Meat and eggs are next, followed by dairy, and the least energy intensive foods are your grains, fruits, and vegetables, which also tend to be your healthier options. So that's good news, right? So we can have a healthy diet and a less energy intensive food system at the same time. All right, so that's it for this one. We'll come back with another video after this. Thank you.